So I hope you all had a nice coffee break. I would like to thank Jim for inviting me to give this talk. I'm so used to preparing 20-minute talks, and so now I have an hour and a half for the talk plus the demo, and I have no idea how long it's going to take. But on the other hand, I'm very flexible, so I think you should feel free to interrupt me whenever if you have a question, because I suspect there is a lot of variation in what people know about the project and what people don't. So it's very likely I'm going to say things that makes no sense to some of you. So please feel free to interrupt me if that happens. Oops. So the talk is about the SICL project. And thanks to Phi, it now officially means SICL implements Common Lisp. So it's a project with the purpose of implementing Common Lisp from scratch. The project started in, I believe, I wrote 2008. So it's been going on for some time, but I didn't work on it consistently, or not even close to full time in the beginning. So it's hard to say how much work has been put into it. So the motivation is that I was dissatisfied with the way current Common Lisp implementations are written. I thought there was an insufficient use of CLOS. There was too much implementation-specific code. I said this yesterday, that I always keep thinking that all these people who implement Common Lisp systems should get together and share more code than they do. And so that was one of the motivations. There's a lot of unidiomatic code in the Common Lisp implementations. I'll show you some such examples due to the bootstrapping techniques that they use. And there's some deliberate decisions that make safe code, which is defined by the Common Lisp standard, really unsafe. One example is, which might have changed since I got this information. In that case, correct me, please. But SBCL, for instance, take your word for it if you say dynamic extent. And so if it isn't dynamic extent, then it crashes. So. There's a lot of duplication of system code between implementations. Some such cases might be justified, but definitely most of them aren't. So here's one example. This is how the classes, class and standard class, are defined in ECL. Okay? That's fascinating, right? This is how they look in SICL. Okay? Which one is more idiomatic? Okay? And of course, this code is ECL specific, and you have a completely different way of doing it in CCL, a completely different way of doing it in SBCL, et cetera, et cetera. This, on the other hand, is the very core of what it means, what those classes mean. This is how symbols are described in SBCL. They use a defined primitive object, and then you have information about tags, how they allocate it. You have information such as setters and getters for various slots. This is how a symbol is defined in SICL. Which one is more idiomatic, okay? So this is a kind of, well, if you know the Common Lisp standard, you know that you can't say meta-class built-in class, but this is system code, so I have the right to interpret that as I please. So one valid question is, why not improve an existing implementation rather than starting from scratch? Well, I think the effort would be I think it would be just as hard or even harder to modify an existing implementation. No, I don't believe any maintainer of any existing implementation would want to modify the implementation in so many ways that would be required for me to be happy. Okay. So it would be the same effort or more. And some of the changes that I would like to see would influence basically an entire code base of an existing implementation. So that would probably not be acceptable. So the initial idea I had in 2008 was, well, I'll just create a set of modules that could be piled on top of a core implementation. Like somebody writes a very core implementation in C, for instance, but it contains only a very small subset of Common Lisp. And then they could take my modules and add up to it until they have a complete Common Lisp implementation. Well, that turned out not to work out because modules must then be ordered by dependency. And each module can use only a subset defined by the previous modules that have been loaded into the system. That doesn't sound too bad, perhaps, but it means that some code will be unidiomatic because it will require, it would have to be written in a subset that doesn't look idiomatic if used like that. And the last line means using a subset makes modules hard to maintain. I should translate that for you, which means that my brain is not big enough to deal with it. And whenever I tried, I would introduce things that I wasn't allowed to introduce because of dependency. So I got really, really frustrated by trying to maintain my own modules. So I changed the idea. I said, OK, I am not smart enough to deal with subsets, so I'll use the full language with each module, including using generic functions and defined with def generic and def method for each module, including CLOS. Using standard classes defined by def class, using things like the loop macro that might otherwise be added at the end. So it's specifically then to do this, to implement CLOS. So as a direct consequence, the new modules are completely useless to an implementation that starts with a small core. And in fact, in order to use these modules now, you have to use the SICL bootstrapping technique, which is not finished yet. So we're in a little bit of a fix here. So if you implement modules this way, you're going to have to run some code in a host Common Lisp implementation that compiles target implementation code. Most of such code is not problematic. It's just macro expanders, and they can usually be written in functional Common Lisp standard, and it's not a big deal. So that can be done. Most bootstrapping techniques work that way. You just take the host implementation, have it expand your macros. But as it turns out, we also need to execute target-specific code in the host. And that's where the SICL bootstrapping technique comes in. And I'll tell you more about why this is later. So let's now just go over a list of new techniques that we invented since 2008. Now, I'll give you a short summary of each one, and then some of them I'm going to elaborate on. So first-class global environments was one of the first techniques we invented, and that's to use for bootstrapping purposes in a host Common Lisp implementation. We needed to isolate the target environments from the host environment. And the host environment is usually spread out. It's functions are contained in in slots and symbols. Method combinations are contained in a hash table somewhere that's the value of a special variable. Some other things are actually contained in as methods in a generic function, and that's the database for some environment objects. So we invented first-class global environments for that purpose. And the main idea here is it has to be fast at runtime as well. And that's the main contribution, I guess. I said in the beginning I thought CLOS was insufficiently used. And the usual reason for that is that generic dispatch is slow. So I felt the need to improve generic dispatch. And as it turns out, I'll talk a little bit more about that. Most implementations use a table-driven technique, which was invented when memory access was roughly as fast as register operations. And that was a couple of decades ago, and things have changed. So the new generic dispatch technique uses register operations comparing to small constants. We wanted to handle from-end better. If you look at what a typical implementation like SBCL does, if you say position something from NT, what it does, which is allowed by the Common Lisp standard, is it actually traverses the list from the beginning. And it remembers the last position that returned true. But that's very unintuitive. If you say from NT, you kind of think that, well, it probably goes from the end. And it's not only unintuitive, it could be performance problematic. If you expect your first element or last element to be close to the end of the list, then you do not expect it to have to traverse the entire list and apply the comparison, the test function for each element before it finds the element looked for in the very end. So we actually traverse the list from the end. And I can see the face there. It's documented in the paper, actually. We do multiple traversals of the list, but only a logarithmic number. So we split the list in half. And we start by traversing the last half, and then we split that in half, and so forth. So, and that turns out to be faster, actually, than usually than doing it from the beginning. We invented macros to simplify the sequence functions. I'll show you an example of that in a second. We invented something called satiation that I will talk also a little bit about more, which basically means filling up a generic function with all the possible effective methods that can be generated from the classes that exist. We invented path replication. If you have a typical Common Lisp code like A equals car X, or let A car X be cdr X, then if you look at the resulting control graph, you will first test whether X is a cons, and it will go that way or that way. And then the paths will merge. And then when you do the cdr, it will test it again. So by splitting those up, you can remember the decision of the first test in the path. And you can avoid the second test. Partial inlining, turns out Charles can say more. It was too slow, wasn't it? Where's Charles? It was too slow? Yeah, you know that too, yeah. But it has the advantage of being provably correct. That is, we did it by local rewriting. And we can prove that each step is sound. And we could prove termination. A more recent thing is call site optimization, which hasn't been quite tested yet, but it has a lot of promise. And it will be able to eliminate basically most of the cases of keyword argument parsing. It will be able to avoid testing for optional arguments and so forth. And so many of the techniques that we rely on in order to make this fast is going to be through call site optimization. We improved the garbage collection by taking an existing technique called sliding garbage collector, which was way too slow even in the book, as described in the book by Jones, and we just made it much better. Garbage collection hasn't been tested because we still don't generate executable code. Debugging support has been partially tested. It's also documented in one of the papers. So I promised an example of macros that improve sequence functions. So here's this is code by Marco. Where's Marco? There. For the method on the generic function position, specialized to a list. And as you can see here, it says with test function, with key function, for each relevant cons, and so forth. Well, for each relevant cons, it takes the from and argument, so it decides whether to go from the beginning or from the end. The with test function and with key function can optimize things like recognizing a key of identity, recognizing a test function of EQL, and not fun calling those, because it will duplicate the body of the method with EQL inline, so to speak. So this looks very nice. And again, my thinking when we did this was, oh, obviously every Common Lisp implementation should now use this version, because all they need to do is define 2 or 3 macros of their own, specialized to what they're able to do, okay? It's not going to happen. There's no reason why it couldn't happen, but it's not going to. So I promised to elaborate a little bit more on C-loss. I'm guessing that most implementations use a version of PCL, which means Portable Common Loops, which was written as a library to bolt onto a pre-ANSI Common Lisp implementation. So you take something that doesn't have generic functions or classes, and you take this new PCL library, and you add it on top of what you have, and now magically you have an ANSI Common Lisp implementation. So that has problems because it assumes this kind of order of dependence that I did not want in the first place. That is, PCL had to be written in a subset that could be accepted by a pre-ANSI Common Lisp implementation. And the way it shows in the PCL implementation is that there are a number of special cases. And those are described, if you look at the AMOP book, for instance, those special cases are not only documented, they're also explained exactly how they solve the problems. Like they say, well, the slots of standard class are eventually going to be reached, and that's a special case, and we don't need to go further, so we handle that as a special case, and here are the slots of standard class. Well, that's exactly the kind of special case that I wanted to avoid. And the other thing is, as it turns out, the C-loss is best described as the result of executing code. What do I mean by that? Well, the slots of standard class. Well, you can, of course, figure out what they are and list them the way you do in ECL. But the best way of figuring out the slots of standard class is to execute the def class of T, the def class of standard object, the def class of class, the def class, and so forth. And that's how that's the best way of getting to the slots of standard class. Similarly, the best way of getting all the methods of, I don't know, compute applicable methods, okay? The best way of doing that Well, you can look at the AMOP book and says it has one method like that and it has one method like that. But the best is actually to execute the def method forms. And in addition, which is allowed, if you factor your classes into superclasses that share the same characteristics, then the exact configuration of your def class forms could change. And so you do not want to manually list the methods that way. What you really want to do is get the result of executing all those forms. Well, that is why we felt the need, that's why we do need to execute host-specific code during bootstrapping, because we need to generate these complete classes and complete generic functions during bootstrapping so that we can execute them for the next phase of bootstrapping. So we cannot do what I believe SBCL does. Charles can probably correct me here. I think the paper by Christoph Rhodes suggests that they compile everything to native code, but they kind of concatenate the part that executes the top-level forms of each file, and they are executed once an initial native executable has been created. They call that Genesis or something like that. Is that correct? Yeah. Okay. But we need to execute the code before we have native code. So what we do is we turn SICL common Lisp code into abstract syntax tree. And then abstract syntax trees are turned into intermediate representation in the form of a pretty traditional control graph with instructions in it. And then each instruction, thanks to Marco, is turned into a host closure that is executed as we traverse the instruction graph. And that closure has an effect on the SICL first-class environment and the objects contained in it, like generic functions and classes and so forth. And that's the kind of necessity we had to deal with in order to get this to work. The other thing in the AMOP book that is also PCL specific is they have a chapter, I don't know if you read it, called Living with Circularity. It has two sections. One is called bootstrapping problems, and one is called metastability problems. And the difficult part is the metastability. What happens is that you need to execute a generic function, but it doesn't have all the effective methods computed in it yet. So you use the methods on it, and you try to compute the effective method. But in order to do that, you have to invoke some other generic functions, and so forth. So you're in this circular dependency. So that's why we invented satiation. It basically takes a generic function and looks at all the methods of it, looks at all the classes that could possibly generate an effective method, and creates that effective method in the generic function. But to do that, we need to execute complete CLOS code at bootstrapping time. So we cannot wait until we have an executable. Okay, so let's talk a little bit about the modules that we have created or that we plan to create for SICL. The first two modules I started with was format and loop. And both use generic functions and standard classes. And they're still modules inside the SICL repository. Now we have many more modules, and we have started extracting them. Okay, so extracting modules means we say, oh, this is sufficiently general that it could be used by somebody else, okay? So let's not make it SICL specific. Let's make it implementation independent. Of course, that's going to create even more bootstrapping problems, because now we have to deal with code that was not specifically written for SICL. Oops. And so that's a new level of ambition that happened maybe 6 months ago, maybe a year ago, or something like that. So we're currently dealing with all the consequences of that. For instance, if you take Phi's condition system, it uses format at compile time to generate gensims. But of course, the printer needs to use format at runtime. But the first format is that of the host, and the second is that of SICL. They cannot coexist in the same environment. So what we need to do, and what I've started to do, is to define a first-class environment specific to each external module that we need to compile separately. We need to see, what kind of requirements does it have at compile time. So that's a large amount of work, and we've just started with it. So the extracted module's concrete syntax tree. I guess I'll just talk about each one of these modules separately. So the concrete syntax tree started life as a SICL module. It defines classes, standard classes that allow us to wrap S expressions into standard objects, because we wanted to attach information to those S expressions, in particular source location. Okay, so that's, other Common Lisp implementations do it differently, but the problematic aspect is symbols, because symbols are EQ. Conses are not a problem. They are usually not EQ, so you can have a hash table. But then when you have a symbol, same symbol can appear many times in source code, and you need to know which occurrence is it. So we wrap every object in one of these concrete syntax trees, and we can attach source information so that this nil is that one over there, and this nil is that one over there. So now that it's been separated out, and it's maintained a little bit by Jan Moringen, I think. Eclector is the great success story. I started life as the SICL reader, and we needed a different reader because we need to create concrete syntax trees when we read source code. And the other thing we wanted to do is I wanted to use the SICL reader for the second version of the Climax editor, called Second Climax, because we need to preserve material that's usually discarded by the reader, typically comments or code that was omitted because of reader macros and so forth. That obviously needs to be analyzed in a text editor. So the SICL reader had this capacity of, had an entry point for returning that kind of material as well. And Eclector inherited that capability. So it was extracted into Eclector, and then Jan Moringen took that on and made it fantastic, like orders of magnitude better than I could ever do it. So if you ever need a configurable reader that can read all kinds of stuff in all kinds of forms, Eclector is your choice. For example, if you want a reader that does not automatically call intern when it finds a symbol, Eclector has a generic function that it calls in order to handle what it looks at as a symbol. And you can intern it if you want. You can put it in a hash table if you want. You can reject it if that's what you want. So you can do things like that with Eclector. It's a great library these days. Okay, perhaps the biggest chunk of SICL was the Cleaver compiler framework. So let me describe quickly what it does. It takes a concrete syntax tree that's this wrapped S expression, turns that into an abstract syntax tree. And that's, I talked about this yesterday, it's equivalent to minimal compilation, essentially. It expands all the macros and so forth. Then it takes the AST and it creates a high-level intermediate representation. That's basically a traditional control graph, except that in the literature, they go directly to all kinds of things like memory operations. The high-level intermediate representation has this additional restriction that all the objects that are manipulated are common Lisp objects. So there are no raw integers, no addresses or anything like that. And that is perfect for things like type inference or other manipulations that depend on common Lisp semantics. And then that is turned to medium-level intermediate representation, which introduces memory operations. So then additional optimizations can be done on that. For example, common subexpression elimination could be done on that level as well, for instance. And then, but it's still back-end independent in that those memory operations must exist in pretty much every processor. And then that is turned into low-level intermediate representation, which is where we introduce registers. And so that's obviously back-end specific. And then that's followed by register allocation and code generation. All of that is currently implemented in SICL. So we do generate code, but we don't stick it in a file to be executed yet. It's still in the form of vectors of 8-bit bytes. So Cleaver currently exists in 2 versions, which is deliberate. One is in the SICL repository, and the other one is extracted. And if you want to use Cleaver for your own projects, you should use the extracted version. Why did we do it that way? Well, as it turns out, CLASP, which is the Common Lisp implementation written by Schaffmeister and his group, uses Cleaver for its compiler. And they needed quick improvements. So whereas SICL needed stability, I didn't particularly want to deal with changes in Cleaver when I was working on bootstrapping. So we decided to split it in 2. And of course, the extracted version has been vastly improved by Charles and by Alex Wood and some others. Have you worked on it too, Costa? A little bit? Yeah, okay. So that's a very complete compiler framework now, the extracted version. So don't try to use the one that's in the SICL repository. The new version uses, the SICL version has just a big graph of instructions. The extracted version uses basic blocks and maintains basic blocks. And SICL may or may not use the extracted version. We'll find out. I'm inclined to do some more research before we do that. And I'll talk about that a little bit later. Claustrum is an it's an alternative spelling of claustrum with AU, which means a room. So it's an appropriate name for first-class global environments. So it's the extraction of the code of first-class environments to a separate repository. It's not in a finished state. As I need more functionality from it, I discover that it needs more stuff. So don't yet attempt to use it. So yes, it was created for this isolation between the host code and target code during bootstrapping. It's also meant to be a feature of the final SICL system. Take a simple problem that occurs all the time. You have two libraries that you need for your own software. This library needs library A version 1, and this library needs library A version 2. And library A version 1 and 2 are incompatible. The way you can solve that with first-class global environments is you stick library A version 1 in one environment, library 2, version 2 in another environment, and you compile the libraries that need it in those separate environments. And then only the interface functions are imported into your main environment. It could also be used for lots of other things. Sandboxing, for instance. Truckler, I'm not going to go into anymore. I talked about that yesterday. Inkless is methods on print object. Currently, it's implemented as a trampoline. We thought that this client idea was good. It might not be, so we might need to rethink that design. InRavena is a version of the pretty printer. If you look in my SICL specification, under pretty printer, it says, we're not planning to do anything about that. There are pretty printers out there. They work fine. And then I looked at the code of those printers. And so I couldn't face adding that code to SICL. So I told people that we need a different pretty printer. And Tarn Burton is his name, I believe, took that up and, in fact, integrated it into Inkless so that he's working both on the printer and the pretty printer. Cyclosis is another thing that we extracted. It's classes and methods for streams. And it was done by Sylvia. Where is Sylvia? There, right? So it's extracted from Mizano. I believe it needs a little bit more work in order to be more implementation independent, but not much. One interesting thing we extracted was cluster, the assembler. And this is one of my favorite pet peeves here, which is there's a lot of use of surface syntax that I find inappropriate. That it be typesetting systems or assemblers or you name it. In the case of an assembler, the purpose of an assembler, at least for a complex instruction set computer, is to take some abstract idea of an instruction like add. And then depending on what it is that you add, it generates different machine instructions for that. And by machine instructions, I mean different instruction codes and encodings of the instruction. Parsing text and producing ELF file is only secondary to what an assembler is supposed to do. So I took the consequences of that and I said, let's just have the assembler take a list of standard objects representing instructions or labels and have it generate a byte vector of the final code. And I think the same thing about word processors and things like that. In fact, they should be defined in terms of what you can do to the internal structure of it. So that way the compiler doesn't have to generate text that is then parsed by the assembler. It just calls make instance with the appropriate abstract instructions, call cluster, which turns that into, if it can, into binary code. So that's finished the tour of all the modules. So let's now see where we are. Well, the bootstrapping technique, I'm very sure it's working. but there are thousands of small little details that need to be taken care of. And I think I've rewritten the entire bootstrapping procedure at least twice, because it's the first time anybody has done anything like that, and I'm just not capable of foreseeing all the problems that can happen. So they happen typically when I've been working on it for a couple of months, and then I say, uh-oh, it's not going to work, so I rewrite it. And the current idea is that we do bootstrapping in phases. And that turns out not to be possible because, like I said, different external modules might need different first-class environments for compilation. And so that turns out, I think it was Marco who said, so that turns into a direct acyclic graph, which is true. We have been using eval semantics for bootstrapping. That is, we take a file and we use what load does on source code. Well, that turns out, first of all, it wasn't great because if you, in the same file, you have calls to functions that precede the call in the file, load will, no, the other way around. If you have a call to a function that occurs later in the file, load will not know that the definition will appear later, so it emits a warning. Whereas the file compilation semantics is supposed to avoid that by basically gathering up all the warnings and only emit the ones at the end that are appropriate. So there's a lot of warnings when we do bootstrapping. But as it turns out, it's not even possible to use load semantics because we absolutely need to compile code in one environment and load it into a different environment. So it's just not possible to do eval semantics. We need this compile file semantics that says generate an abstract syntax tree using that environment and then load the resulting code into that other environment. So that's what we're working on now. And yes, the simple call site manager has not been written yet. So that's a simple call site manager should not be too hard to write because it will just essentially insert trampoline code that does whatever the prefix of every function does, which is check that the number of arguments is correct, parse the keyword arguments, and so forth and so forth. But of course, that's meant to be much smarter ultimately. Nobody has interrupted me. Is it because I speak too much? Future work. So there are functions that we would like to extract to separate repositories. I mentioned format and loop. They're still in the SICL repository. They should definitely be extracted. We discovered a bug in the loop code when it uses the AND loop keyword. So any maintainer of loop would have to address that at some point. The sequence functions are still in SICL, aren't they? Yes. But there's absolutely no reason for that. They are completely written to be implementation independent, so they should be extracted. There's a big chunk of code for high-level list functions like catter and cadutor, of course, but also mapcar and association list code and stuff like that. All of that is completely implementation independent. Hash tables I haven't looked at recently, but I believe they are sufficiently implementation independent that they could be extracted. Jan Moringen, that I mentioned now a couple of times already, has written a fantastic library that he calls S-expression syntax. What it does, it contains parsers for things like special forms, standard special forms, lambda lists, declarations, type specifiers, standard macros, including loop. So he parses every loop, possible loop clause. And of course, this being Jan Moringen, it's probably documented, completely configurable, generates correct error messages, probably has error recovery, or will have, or something like that. So this kind of code appears in every Common Lisp implementation. There is somebody that's going to check the syntax of let. There's somebody who's going to check the syntax of labels and so forth. So what I want to do is to delegate that to this external library. I mean, that includes SICL. We do verify syntax and so forth. But it's not quite finished yet, which is, with Jan Moringen's standard, doesn't actually mean much. I think it's perfectly usable. But the problem is that it itself uses other external libraries. So in particular, a library called parser.packrat, which is a packrat parser, and something called the Architecture Builder Protocol. And so normally, you would give up and say, oh, OK, I can't deal with that. But I think SICL should deal with it. We should figure out how to compile each one of those libraries so as to be able to eliminate all of that code from the SICL code base. But it's going to be a little bit more work. Some more future work, and this relates to whether SICL will use the extracted version of Cleaver or not. There's a thing that I have this hunch that there is a strong relationship between static single assignment form and global value numbering. And I believe global value numbering is strictly more general. You can understand part of the hunch because SSA conversion might give a quadratic blowup. Well, the amount of information that global value numbering generates is quadratic because it's pairs of program points and value numbers. Okay, so that can be quadratic in size as well. And so I believe that SSA is just a subset of global value numbering where you take into account basically only assignments. And you represent the result of SSA in the form of lexical variables, whereas in global value numbering, it's represented as pairs of program points and value numbers. So what I would like to investigate is whether this hunch is correct and see whether we could use, have the register allocator work on the result of global value numbering instead of working on lexical variables. And if we do that, we could let the register allocator do rematerialization, which means that, say if you have an addition and you have two arguments available, you might choose to store the result of that addition. And that used to be the best way of doing it a couple of decades ago. Nowadays, if you do that, it might generate a memory access. And instead, it might be cheaper to actually redo the addition. Well, this information is explicit in the result of global value numbering. So if register allocation works on global value numbering, the register allocator could choose whether to save the result of the operation or to redo the operation later on when it's needed. And so that is related to representation by a man named Cliff Click, who seems to be a very knowledgeable guy. He invented something like the sea of nodes representation of intermediate code. Basically what it does is it has chunks of purely data flow code. So it has no control information. And there's control information only when there's a choice point, like an if, and when there's a merge point, like when two control branches merge. That's the only time when he uses control information. In between, there are these seas of nodes that are only pure data flow analysis. So the order of execution doesn't even matter. And I think that's close to the right way to do it for the register allocator to be optimal. But this is just a hunch, so this is definitely future work. And this is why I haven't already made up my mind to use the extractor version of Cleaver, because I want to investigate this first. Also future work, Clausos is a design of an operating system that I would like to see based on these ideas, especially the ideas of first-class global environments to isolate between either separate users or separate roles of the same user. And like I said briefly, I want second climax to, it already uses a collector to parse the buffer contents at typing speed. I would like to see whether it can also execute a few passes of Cleaver at typing speed so that you would get very, very good feedback at typing speed in the editor, so you don't have to type Control-C, Control-C, or whatever in order to get that feedback. If anybody wants to maintain some modules, then we're looking for maintainers for these. Claustrum and Truckler don't have any maintainer, I believe. Whenever I harass Marco to improve Truckler, he complains, and he doesn't have time anyway. Loop and format have not been, oh yes, you complain. Loop and format have not been extracted, but they are sufficiently independent of the implementation that they could be. So here's a list of collaborators. I am pretty sure I have forgotten a few, but so Alex Wood worked on Cleaver, CST, and C-type, which is, we gave up on Baker's type inference. And he created C stands for, what does C stands for in C-type? Nah. I'll remember it later. Charles Zhang is who is here. Jan Moing, that I mentioned several times. Marco is here. Haley Patton worked on hash tables. Daniel Kochmansky couldn't make it. He's been working on Claustrum. Longil is somebody I don't even know. It's a Swedish person, worked on Inkless. Sylvia worked on cyclosis, I already mentioned. I mentioned Tarn. Nuxi or Gnuxi, somebody from the UK that I also don't know, worked on cluster, and in particular, the disassembler. And I would like for at least one more person to understand the bootstrapping procedure, because if something happens to me, then this information might be lost, and that would be a little bit unfortunate. So, thank you very much. Questions will be fine now, and
Let's.
I think there's a demo following this, which I believe is very short. So
How much time do you need for the demo?
I don't know, 10 minutes, maybe 15 or something like that.
So do we have the programming people to walk the?
To walk the what?
Normally we have.
Ah, yes, yes.
I have two questions, quick questions. The first one, you mentioned a module for storing information attached to S expressions, I believe. Could this be used, for instance, to remember macro call sites and recompile them whenever macro definition changes, for instance?
That you would have to ask Jan Moingen. That's his module. You mean the S expression syntax module?
Maybe, I don't remember the exact one.
Or maybe you're talking about the call site optimization?
No.
No, okay. Well, then it's probably Jan Moingen stuff, and
Okay.
I don't know.
Okay, next question. How do you come up with all those beautiful module names?
Basically, well, you can go to a website and say, give me all the names that contains SICL, and then you remove the K. Okay, stuff like that.
Okay, so 2 questions about the bootstrapping technique. So you're defining all your objects in terms of def class.
All my what?
So you're defining all your objects,
yeah,
like common list objects, in terms of def class. So do you see a way to not require the mop when you're from your host, because
No.
the ANSI specification doesn't specify?
No, I don't see a way.
Okay, yeah, that would have been nice, because I think if we were to use this technique in, say, SBCL or other implementations, sometimes they'd like to require the host just to have the ANSI stuff.
Sure.
Okay, so then the second question is, so the SBCL example you showed has information about like low tags and the type tagging information.
Yeah.
And so that information actually wasn't present in your
Right.
like the def class with the built-in class. So would you just have another macro for that, or would you incorporate it some other way?
It's much easier than that, actually. SICL has the only immediate objects are short floats, single floats, sorry, cons cells, and fixed nums, characters, okay? Everything else is a standard object. Okay, so I can, so the symbol example there is just the definition of a standard object. And all the standard objects have class information stored inside them. And the same technique is used for accessing those as is used for other standard objects or instances of standard classes. So there's nothing special to be done. Yeah, that doesn't need to be. So where do I store the tags? Because that needs to be tested for. I don't need to store the tag in a symbol because it has information about the class stored in it. And so the tag used on the pointer is the same for all standard objects. And that's hard-coded. Those are hard-coded.
Those are just hard-coded, but you wouldn't use a macro or something to encode that information? You have to repeat the question again.
It's hard-coded, but wouldn't I use a macro to encode that information? I probably would, but I probably don't. The stuff like that needs to be cleaned up at some point later, but right now it's probably duplicated in several places, then it shouldn't be. That's correct.
Could you go back to the slide where you discussed intermediate representation SSA and the other?
What representation?
SSA.
Oh, I see. This one?
Yeah, I see. I wanted to ask what's the difference between C of nodes and basic blocks?
Those completely different. Basic blocks Basic blocks is a traditional control flow graph, except that you group together linear sequences of instructions into one thing called a basic block. C of nodes, on the other hand, removes the control information inside that a block, and it turns it into a data flow graph. So the only information you have is that this variable is the sum of those two variables, and this variable is the difference between those two variables as a tree, if you like, or a DAG. But it doesn't order them in the control flow. And because it's purely functional, if you want, it can then be laid out in any order you please at the end.
So you mean, say, the instructions within the basic block are not anymore ordered?
There are no longer any instructions inside a basic block, essentially, if you want to put it that way. There is just this data flow graph.
So there's a question now from the people online. If there was talk about replacing the parser, backrat, why and with what?
If
There was talk about replacing the parser, and then they mentioned backrat, why and with what?
no, the talk was about replacing explicit code to check syntax for things like special forms, which is now very, very specific. Like if the length is less than that, then complain. If it's not a const, then complain because of that. And that code is what I want to throw out and replace with this S-expression syntax library, which uses the backrat parser. And I just want to throw out all my specific code and use whatever the external library does.
Okay, now there's a second question here from Jack Daniel. How likely is it that SICL will be bootstrapped from something without usable mob implementation?
0. No, we absolutely need the mop machinery in order to execute, in order to create all those CLOS thingies like classes and generic functions by using the method of executing code. We can't do that without the mop.
Here. I will start by complimenting about one thing I like a lot. I saw in the SICL code a few years ago. It's the conditions. There's a condition for everything. And I quite like that idea that it's not just a single type error, a single unbound error.
Yeah.
Everything has a specific condition, which is really good to debug, to see what the compiler is doing. So one of the things I was seeing here in the sea of nodes is that there are a few, just to add a comment, I think volatile accesses and locks also have that semantic of merging. So those are the only points where data order matter.
Yeah.
Everything else doesn't matter. If you are using additions that are not visible in other threads, for instance, they may be done in any order, like in C++ nowadays, actually.
And I believe the result of global value numbering could be expressed exactly that way. I mean, it is expressed exactly that way. It says, you know, this variable is the result of adding those two variables, and that's it. Yeah.
And finally, a question. I normally see other programming languages or environments which bootstrap. At some point, they only depend on themselves. For instance, C#, Free Pascal, etc. They, at some point, decide not to depend on other implementations. Will SICL eventually go through that route?
Oh, the SICL bootstrapping technique is implementation independent. So once SICL becomes fully functional, SICL can bootstrap itself. But I have absolutely no intention of making the bootstrapping technique SICL specific. It should still work on any conforming Common Lisp implementation plus the meta object protocol.
I tried to integrate the loop thing that you wrote into Clasp, and then I compiled a bit of quick Lisp with really bad results, because most of the loop users in the free world are not following the specification.
Yep.
How to deal with that? Even if I compile Slime in the trace dialog extension, I get a warning that the loop is wrong.
Yep.
They do all this 4 until 4, which is not legal.
That's correct. In fact, Zach is using SICL, has been known to use SICL loop in order to check libraries that are in QuickLisp, and I believe he complains about it. So, but the solution to this problem is to allow for SICL loop to do the traditional but non-conforming stuff if that's what you want. But, you know, this is not high on my list of priorities, so you're going to have to wait.
Any more questions? Okay, thanks very much for the
Sure.